Some common examples of isotope problems are on the board. In the first type of problem, they might give us three different structures that are drawn and tell us that the red dots are neutrons, the green dots are protons, and then ask us which are isotopes of each other. So my answer for this problem would be found by counting up the dots. Remember that the rule is that isotopes have to have the same number of protons and a different number of neutrons. So when I look at A, I see that I have 4 protons and 3 neutrons. And on B, I have 4 of both. And on C, I have 3 of both. So it looks like A and C and A and B are isotopes of each other. But in truth, remember, they have to have 4 protons in each. So the only one that has the same number of protons is A and B. And that means that as long as the neutron number is different, my answer would be A and B. Since A has 3 neutrons and B has 4, my answer is A and B. Now, this is another way of asking the same question. And in this example, they've given us a chart with the pin number for 4 different atoms, and they've asked us to figure out which are isotopes of each other. Now, the trick is to ignore the electron value because I cannot look at electrons to determine isotopes. The definition of an isotope is how many protons having the same number of protons and a different number of electrons. So I need to look at the proton value first, and all of the protons have to be the same. So number 3 is out. Then I have to compare my number of neutrons. And number 1 and number 2 have the same number of protons and the same number of neutrons. So they're not isotopes, they're identical. And number 4 has a different number of neutrons but the same number of protons. So it is an isotope of 1 and 2. Now I have listed here that 1 and 4 would be isotopes because they have equal number of protons and a different number of neutrons, and that's true. But you could also say that 2 and 4 are isotopes of each other for the same reason. Now, how do you find the pin number when you are looking at the periodic table? A box on the periodic table will have some common components: the atomic mass, the symbol, its name, and the atomic number. Now, to find protons and electrons, all you have to do is find the atomic number because the protons and electrons are equal to the atomic number. That means that if I have 5 for my atomic number, then I have 5 protons and 5 electrons. And the phrase that I use to remember this is that there's no math in PE. So protons and electrons, I don't have to do any math. I just look at the box, find the number that's a whole number, and that is my value for proton and electron. Now, my neutron number is a little bit more complicated because I have to remember that the atomic mass is protons plus neutrons, and the proton number is the same as the atomic number. So if I want to find neutrons, what I'm going to do is subtract the mass minus the number and get the number of neutrons. So for this boron sample, I would do 11 minus 5 to find 6 for my neutron value. Now, the phrase I like to use is Jimmy Neutron likes math, so round and subtract. Now, you notice I took the 10.811 and rounded it to 11. Then I subtracted the 5 to get the 6 neutron value.